This is the 12th question of TMUA 2023 exam paper 2. This says, in this question, P is a real constant. So P is a constant here. The equation sin x cos square x is equal to P square sin x has n distinct solutions in the range 0 to 2 pi, where 0 and 2 pi are included. Which of the following statements is or are true? Statement 1 says, n is equal to 3 is sufficient for p greater than 1 and n equal to 7 only if p lies between minus 1 and 1. Let us tackle this question one by one. This is a very interesting question. So I have been given sin x into cos square x is equal to p square sin x. P square sin x. What I'll do is I'll take it on this side. So this becomes sin of x times cos square x minus p square is equal to 0. This becomes sin x cos square x minus p square sin x. You take sin x common. So it becomes sin x into cos square x minus sin x into p square is equal to 0. So from here I conclude that either sin x is 0 or cos square x is equal to p square. So if cos square x is equal to p square, that means cos x is plus or minus p. Okay. If sin x is 0, x lies between 2 pi and 0, including 0 and 2 pi. So if sin x is 0, from here I can get x can be 0, pi and 2 pi. These are the solutions in this scenario when sin x is 0. Now we will take care of cos x equal to plus minus p. So cos of x is equal to plus minus p. Now, first of all, we have to look at condition by condition. The first condition is that if p is equal to 0, if p is 0, what do I get? Cos x is equal to 0 or x is equal to pi by 2 in that range. Okay, because x lies between 0 and 2 pi, including 0 and 2 pi. So x, if p is 0, then there is only one solution, x is equal to pi by 2. Okay. Or actually there will be another solution, 3 pi by 2. Okay. X equal to pi by 2 and 3 pi by 2. Pi by 2 and 3 pi by 2. Okay. So if p is 0, x is pi by 2 or 3 pi by 2. Now if p is 0, then if p is equal to plus or minus 1. P can be plus minus 1. Okay, if cos x is p, let's p is 1. So cos x is plus 1. If p is minus 1 and cos x is p, then cos x is minus 1. So that is also possible. So if cos x is equal to plus minus 1, then what possibilities do I have? X can be 0, pi or 2 pi. Okay. So from here, I get x can be 0, pi or 2 pi. Okay. Now p is 0 and p is plus minus 1. Other possibility is, right here again, cos x is equal to plus minus p. Other possibility is p lies between minus 1 to plus 1, where p is not 0. Okay, when p is not 0. Because p is 0 is another case we have already taken into consideration. Now, if p lies between minus 1 and 1, and let's say cos x is p, I'm just taking the positive side of it. So if cos x is p, then p lies between minus 1 and 1. This is the first quadrant, second quadrant, third quadrant, and fourth quadrant. P cannot be 0. Okay. So if p is positive, let's say I'm taking the case cos x is equal to p. Same if it is negative p, you will get the same values for x in terms of just negative. Quadrants might be different, but the values of x will be similar. What you get with p. So when cos x is some given value p, which is a constant. So it is if the constant lies between minus 1 and 0. That means the constant is negative. That means that angle lies between, if that cos x is negative, it is either in second quadrant or third quadrant. Okay. Because if it is in first or fourth quadrant, cos is positive. Okay. So this x angle might be somewhere here. Let's say this is theta 1, or it might be somewhere here. Let's say it is theta 2. When I put cos x is equal to minus 0.7, let's say. So if it is minus 0.7, it will either lie in 2 or 3. Okay, so there are two possibilities that I get from here. But when P is between 0 and 1, if P is between 0 and 1, that means let's say P is plus 0.7, then cos x has to lie between quadrant 1 and 4. Because in 1 and 4 quadrants, cos theta is positive. So in that case, let's say there is theta 3 angle, and let's say this is theta 4 angle. This is theta 3 and theta 4 angle. So when P lies between minus 1 and 1, I get 4 solutions. That will depend on the value of P, what the values of x comes out to be. Okay, but there will be 4 solutions. 2 in these second and third quadrant when cos x is a negative number, and when cos x becomes a positive number, then 2 in the positive quadrant. Okay, because if you have taken P as 0.7, then cos x is 0.7. That will give me these answers. But cos x is also minus P. So cos x can also be minus 0.7. So the answer will be in these two quadrants. So I will get 4 solutions when number of solutions are 4. So if P lies between minus 1 and 1, x will have 4 solutions. Just keep in mind, then x, in this range, P is not 0. P is not 0. Because if in this range, if P lies between minus 1 and 1, P can be 0. But if P is 0, there is another case for it. Okay. Now the final case, if P is greater than 1 or P is less than minus 1. Okay. Write it here. Final case, let me write it here. If P is greater than 1 or P is less than minus 1. So if P is greater than 1, can cos x be greater than 1? Or can cos x be less than minus 1? That is not possible. So there is no solutions for that. X is 0 solutions. So if P is greater than 1, P is less than minus 1, I get 0 solutions. Okay. So now, what do I have? N is equal to 3. So first of all, let me create a table here. So here P is 0. I will write N. Here P is equal to plus minus 1. And then here P lies between minus 1 and 1 such that P is not equal to 0. Okay. And then P is greater than 1 or P is less than minus 1. These are the cases that I have now. These are the 4 scenarios. Now in the first case, first of all, definitely I will be getting 0 pi and 2 pi as 3 solutions from sin x equal to 0. When P is 0, I get 2 further solutions, pi by 2 and 3 pi by 2. So if P is 0, N is equal to 5. I get 5 solutions in all. N is the number of solutions. Okay, N is the distinct solutions in that range. Now if P is equal to plus or minus 1, I get here 0 pi and 2 pi. P is plus minus 1. Again, same 0 pi and 2 pi are being repeated. Okay. So I get N as 3. If P lies between minus 1 and 1 such that P is not equal to 0. So in this case, I get 4 solutions from here, and 0 pi and 2 pi are the 3 other solutions. So 4 and 3 total 7 solutions I get. If P is greater than 1 or P is less than minus 1. P is greater than 1 or P is less than minus 1. So here I don't get any solution. Here I get 3 solutions. So I get 3 solutions. This is the table I have. Now if I go to the options, N is equal to 3. Is it sufficient to say that P is greater than 1? N is 3. N is 3 here. N is 3 here. So in this case, P is actually equal to plus minus 1. And in this case, P can be greater than 1 or can be greater than or can be less than minus 1. So N equal to 3, you can't for sure say that P is greater than 1. So it is not a sufficient condition. So the first option is not a sufficient condition. Looking at the second option. N is equal to 7 only if P is between minus 1 and 1. Now there is a catch here, but you have to understand it. P is between minus 1 and 1. What is the statement saying? Had the statement stated, if P is between minus 1 and 1, then N is 7. Then it would have been a false statement. Because if P is between minus 1 and 1 and N is 7, then P is not equal to 0. You have to give further condition. But I have been given that N is 7 as the first condition to move. So if N is 7, I'm saying. So No, n is 7, I'm stating. So n is 7 is true. So I have to assume n is 7. When n is 7, where does p lie? P will definitely lie between minus 1 and 1. It will not be 0, but it will definitely lie between minus 1 and 1. So if n is 7 here, means 7 is 7, only when p lies between minus. Had I been given this statement in reverse orders, like I would have been given that p lies between minus 1 and 1, that means n is 7, which is incorrect. Because p lies between minus 1 and 1, n can be 7, but p equal to 0, here n becomes 5. Okay, and 0 also lies between minus 1 and 1. But I have been given a statement that n is 7. So n is 7. That means p has to lie between minus 1 and 1. It can't be 0, but whatever the value of p is, has to be lying between minus 1 and 1. So this statement becomes correct. So statement 2 is correct only with answer option C is right. Quite an interesting question.